Hello again, my name is Valentyn Vynogradskiy, and I will turn on my presentation, sorry. Okay, I'm software developer in a DataArt. I like JavaScript, hopefully mostly of you do. Today we're going to talk about the event loop and how it works. We will be talking about how it works in browser mostly, but I will highlight some differences with the node.js as well. And I want to know a couple of things about you all people. First of all, please raise your hands who work with JavaScript as the first technology, like node.js or Frontend. Okay, super. And please raise your hands who know, heard, or like closely know these two guys, Philip Roberts or Jake Archibald. Philip Roberts, 1, 2, okay, super. So today my talk makes sense. And yeah, where do we start? We will start from the JavaScript engine or the runtime. All browsers have JS engine. For Chrome it's I have this thing. For Chrome it's V8. For Firefox it's SpiderMonkey, JavaScript Core in Safari, etc., etc. So what does the runtime do? It compiles code. It's like very basic. We are not going to in deep into how the runtime works, but like very simplifying. It compiles code and executes it. And for Node.js it's V8 because it's built on base of V8. And if we will draw the schema of the runtime, very simplified, it would look like this. It's a heap and a call stack. So heap is not in our scope, it's just memory allocations for for variables and for arrays, for objects, etc. And the call stack also, it's like execution context. It follows line by line for your code execution, and we will be talking more deeply about it. This is like our main scope. But for example, V8 is available for download, and you can start it as standalone. But if you do, and we'll execute some kind thing like set timeout with a callback and some time, you will get reference error. Set timeout is not defined. It's not this function is not defined, and that means that set timeout is not in runtime in JavaScript engine. And for example, for browser, it means that the picture is not full for everything of that. So if we are going to more like complete picture, it would look like this. Call stack. I didn't draw the heap. APIs, task queue, and this like event loop is our main theme. First of all, I want to show you how you all already saw the call stack in your development. This is I guess all of you use the Firebug or DevTools. So if we will go through this very basic example, we see this is everyone can see this code from the back, can read. Okay, super. So this is the simple function call. Superman vs Batman. It calls another function, it calls another function, it calls another function, and that function throws the arrow. And if I will run this code, I will get the error. We all saw these errors. They are annoying, but sometimes they help. And the message. And if you wrap this down, we will see what was in call stack when the error was thrown. So the call stack fulls, and it meets the error, and bam, it's like shows the error, and we can read the call stack. And if you are developing, for example, on C#, we call it stack trace sometimes. Yeah. So this is kind of visualization of call stack for everyone who cares. Yeah. So web APIs. If you will go to the magical W3C convention interface, you will find the web APIs for browsers. They define some timers. It's like set timeout, set interval, set immediate, and only in IE, I guess. And all Ajax calls, DOM elements like get element by ID, get element by tag name. And it's not the full picture because they have like lots of different stuff, but this is kind of, you know, mostly usable. And here is the difference for Node.js. The whole process is almost exactly the same, but only the name changes. So we have Node APIs or C APIs, and they provide some functionality like set timeouts and etc. And they working with like in pair with libuv. libuv is a cross-platform library for asynchronous calls. So libuv is just provides asynchronization, and the function definition provided by the C APIs. So, but all other stuff is like exactly the same. The process of how they move from one thing to other, we will look at like. Let's go to the very first example. It's like nothing special about this example, but just you to get used to how I will visualize this stuff. Okay, so first of all, you know, if you debug in, for example, in DevTools, you will see that first of all we are going to the function definition, and then we are going to the execution of the first function. Yeah, on the bottom, Superman to do call and call stack main. It shows that we are in the main thread. It's like we are in your script, and then we are inside the Superman to do. You can follow the error. And then we are going to first function call, then console log, then console log end, and we are going like after return we are going to the like up level. Console log, console log, console log. We are step out from the Superman to do, step out from main, and we're done. Okay, any questions so far? No? Okay, super. So let's take a more complicated example. Now we have set timeout, and I got rid about the console log because it's boring. I will just show the function level. So we are again in the main in the script level. Sorry, script execution. Call stack is in script execution. Then we go to the set timeout, which now call the web APIs. Web API start the timer with the time we specified, like 1 second here, and then call stack just lose this function, and we can continue with our with our execution. So timer like on the asynchronous run asynchronous, and we are continuing with our script. Jira request from client, call wife, buy milk and bread, and then when we are done here, and timer already execute this 1 second, it goes to task queue. Then when the call stack is clear, the event loop can move from task queue, one task, to a call stack, and it's executed. And we're done. So one more interesting thing about this is that when we are in this position, okay, no, sorry. When we are in this position, the call stack blocks the UI rendering. So we can show the UI rendering like a request somewhere here that has if with a can render function, and this can render function asks, does the call stack is clear, and if it does, it could render. So actually render request wants to happen as frequent as possible. So you may hear the 60 FPS in some games or somewhere else. It's like means around 16 milliseconds between the each rendering request. So it's like can render yes, can render no, can render yes, can render no, and it renders if it's yes. So for example, if okay, I can do this. Like okay, so for example, if we would take the example, I wrote the delay function. It's with the while loop just blocks the call stack for okay, let's do it for I don't know 10 seconds. For 10 seconds. And after 10 seconds it makes console log. So if I run this, nothing works. UI blocked because call stack doesn't allow to re-render. But browser remembers every click I did, and once it's done, it's starting to be, you know, insane. It's doing some random stuff. Okay, I rather close this. It's not usable anymore. So so what's happened? Something in call stack, it asks, can I render? No. Can I render? No. And for 10 seconds. And the UI is blocked completely. Yeah, so this is like basics of the event loop. And any questions now? Maybe? Because we are going like deeper. Okay, super. Let's look at this example. And let's try to predict with things we already know. Set timeout calls the APIs. Move function for 0 seconds to APIs. Then promise resolve moves to APIs. Then they move to task queue. Promise move to task queue. And then call stack. And our log should looks like timeout resolved and promise resolved. I know there is typo, sorry. But let's try to execute it. I already have it. 12. I will create. And bam, promise resolve first. Sorry, it's I clicked 2 times. Sorry. Promise resolve first. So why does it happen? It's like it means that our picture again not full. So let's look. We are going to set timeout. It goes to APIs and timer start. It's like STCB. It's like callback. Promise goes to APIs and then timeout, and then whoa. Okay, so this is Microtask queue, and this is something different. If task queue is something that runs like after the call stack is clear, then Microtask queue is something that runs just after the last call stack task. So what does it mean? It means it doesn't clear the stack for a rendering request. So let me show you one thing. This is 10 promise calls. They like exactly the same. 10 promise calls, each contains delay for 1 second. I know this is not real, you know, we doesn't have 1 second delay in our code. But if we will write for 10,000 elements, and there is some calculations that took like I don't know, 0.01 second, and if you will write it in 4, it would be 100 second. I mean, calculate right, 100 or 10. Okay, but you know, 10, 100 for UI, it's the same. So let me clear. So promises are resolved through the Microtask queue. So if they would be implemented like a tasks, we could do something between each 1 second. But for microtasks, we are not able to do anything. So if you are working with promises, you should be aware that if you are resolving promises like continuously in some for or some other loop, that might cause the leaks in UI. Boom. Okay, I already said about this. And yeah, so let's go to one more example. This is like a little bit more complicated, and I know that this sometimes can blow the mind, but it's even differently executed in different browsers. So I will show you. First of all, we are having two on-click registration for, oh sorry, there is problems with it. Okay, super. So this is simple HTML, this is simple CSS, it's not in our scope. We have two on-click events that are added as event listeners to inner and outer divs, and inside the on-click we are executing console log, then we set timeout, then we resolve the promise, and then we have a registered mutation observer for attribute change on the outer. Outer, it's like the div on the, and we change the attribute. So if we will click on any of this div, let's assume that we are clicking on the inner. Remember this bubbling thing that we click on the inner element, and on click goes to the inner and then to the outer. So first of all, we will see this console log, which is like logically, and then set timeout is a task that goes somewhere on behind. Then promise resolve, this is the microtask that should goes like just after, and the set attribute change is a mutation observer. I will spoiler you, this is also microtask. And let's see what happened here. Bam. First click, yes, promise, because it's microtask and it's registered first. Then mutate, then click, then promise, then mutate, because it's 2 times, remember bubbling, and then 2 timeouts, because 2 timeouts, like, they executed just after the call stack is clear. And this is like kind of understandable, but let's go, for example, to Firefox, and sorry, I should open it before I start, but I completely, oh come on, whoa. Firebase, woo, and run. Why you didn't run? Okay, you should click. Okay, click mutate, promise timeout. So yeah, so the Firefox and like Safari do it the same as Firefox. They are doing in different order, because they are handling the microtask for promise for some reason in a different way as Chrome do. I don't want to show you what happened in IE, but it has also different things. So what the summary of this is, like, it's unpredictable, and you should really carefully use it in your code, because microtask is a task, they might sometimes blow your mind. And 2 more examples that maybe show you some interesting thing about this microtask and task sync is this example. I set timeout for 0, yeah, for 0 seconds, and then I use this delay function for 5 seconds. And if we run this code, we log the date, and then we log callback called with the date. So this is the first console log, then delay, and then if you will look at the seconds, you will see that here is 22 and here is 27. So set timeout doesn't guarantee you that callback will be executed like after the time you specified passed. It guarantees that it would be executed at least at this time. So call stack may delay your callback execution on some time, so you should be aware of that. And yeah. So one more question is how to differentiate like tasks. It's like microtasks from microtasks, and you should read specification of HTML. It's defined there, but it's really boring. I will show you like the most usable thing, and I could recommend you to read the articles from Jake Archibald. He showed something there, very interesting. And yeah, questions. Yeah.
Where is event bubbling here?
I guess it's like event bubbling is not here. It's like it's just events. You know, events is also tasks, like microtasks, but I forgot to specify it here. So yeah, your events on buttons, for example, they also go to the task queue. Thank you.
So is there like a specification for this in ECMAScript or somewhere? Why is it working like differently? There is no specification for this, so how to actually run the microtasks and tasks?
I guess there is some kind of specification, but you know,
nobody cares.
Ask IE developers like where is the specification for most of the thing, but I don't know. I read the article that says that like Chrome take cares about microtasks execution in most like logical ways, because it puts the promises and mutation observer on the same level, and you know, Firefox for some reason handles differently promises from other microtasks. So I believe that Firefox guys should move their implementation to Chrome one, but it's like just my opinion, because I don't see any difference between mutation observer and promises from the perspective of logically handling the microtasks.
Okay, thanks.
One more. Here you covered only the main thread, so I'm asking, what is the behavior? Do you know the behavior of micro and micro tasks in web workers?
In where?
Web workers.
No, sorry,
Okay, so only it's just interesting because it's pseudo threads, so the micro tasks there might behave a little bit differently.
yeah.
Quite an interesting topic. Okay, thank you. One more question. Okay, thank you for your questions. And now.
Okay, thank you all.
Hi there. My name is Nikolay Vinogradskiy, and give me a second. So I would like to talk to you about Firebase. Anyone used Firebase before? Anyone familiar with this technology? Yeah. Okay. So so what is this Firebase? Firebase is a backend service for your for your applications like Android, iOS, Windows, web. It doesn't matter. So what it offers, that's you actually don't have to use backend using those technologies. Just developing in plain, I don't know what kind of languages and what's your specializations, but it just takes away backend. So okay. So Firebase is not a relational database. It's NoSQL. If anyone of you familiar with Redis, Mongo, Cassandra, so this is NoSQL technologies, NoSQL data stores, and usually they handle larger amount of data on many machines. So NoSQL is better than relationship databases, and Firebase using NoSQL. It's the structure of the Firebase and how the data organized on the Firebase. It's similar to Redis. It's a key value. So for every single piece of information, you have a unique key, and you have data attached to this key. Yeah, that's what I said. It's really similar to Redis and MongoDB. Redis because Redis is a key value store. Mongo, it's more document-based database where you can nest a lot of data, where you can it's supposed to handle large amount of data in a single node. So hosting, Firebase is hosted for you. So what it's mean, you don't have to install servers, databases, handle all this configuration. It's you just I will show you in a minute. You just go to Firebase console, and you have pretty much all the options you can need in to develop your backend services. So usually so this slide actually shows you in a kind of typical way. Your client communicates with the server, your server communicates with the database. It goes back to the client, and it goes to the server and goes back to your client. This is not the case with Firebase. So I will show you the Forge. It's called Forge, the console of Firebase, and I can highlight some of more features. But before that, Firebase is URL oriented. This means that every specific data has the unique value, and this value it's generated as a tree, as a URL. As you will see in a minute. Okay, so let me show you Firebase console. Just a second. So yeah, this is my Firebase account, and this is me. So what did I do today? I just created a new project. So if you when you create a new project, you automatically just create a database reference, and in a few clicks you just start using it. So I'll go to my sample project, and for in a few minutes I'm going to talk about some mobile development. For now, I just stick with the web, and I'll take this this last feature, which is pretty much for the web. This is how you initialize your Firebase. You just create your project, and in your Firebase console, you got automatically just generated those API key, domain, and some other information. So this is how it looks like. This is our console. Let's go over a couple of the features which Firebase provide, because it's pretty much important, because when we dealing with the kind of servers, like for example, I'm a JavaScript developer. I'm usually working if I need a server, I probably will get for node.js and do some. So what would I do when I set up the server? I probably need a database. I probably need some kind of authentication to verify if my users. Just to verify users, if I need some statistics, I need to do some verification if the users are allowed to view some content in my storage. Couple of other features. Authentication by default, Firebase provides you with the standard email password authentication, but you also could have Google, Facebook, Twitter, even GitHub. So it's there is a plenty of social networks which you can authenticate with. This is my actual database, which I will work with in a second, just to show you what it is and how you manipulate your data. So as you can see in a URL, when I gonna go to any kind of point of my data, the URL gonna be changing. This is what I meant when I said that the Firebase is URL based. It means that you have you can view your data as a tree, or maybe as a graph, where look at the structure of my data, and if I go to any specific point and try to access any specific data, you see that my URL's changed, and this link actually it's I can get JSON data anywhere. This is kind of working database which uses to manipulate my data by going through the trees and and unique keys. That's how it's structured. So we have a couple of more features like storage. It's more like for some kind of bigger files, like pictures, like videos, and it's premium, but for sure database it's as a service. Firebase is premium service, but you can easily have a working website about 100,000 users, and you wouldn't pay a dime for it, because, well, it's free till the certain point. So hosting, I will mention. I will go through hosting later. You also, while you having real-time database in somewhere on the web, you also Firebase also provides some hosting. You could actually yesterday I was listening a talk and transferring your domain to the Firebase. It's absolutely no cost. Google kind of pays for it. By the way, Firebase is bought by Google. If you're interested in this information. So we have a couple of other additional things in Firebase like testing, crash reporting, notification, as you see. I will not go through all of these topics because Firebase as a one topic is pretty big, and I will highlight only a couple of features just to kind of try to get to in this realm, and maybe you're gonna be interested in developing Firebase. All right. So back to slides. So real time, what does it mean? Usually, when you're trying to kind of get some kind of data in the web, you have your client. Your client access to the server, and the server responds with the response. It goes to the client. But connection got lost, and for example, if you need if the database had some kind of changes, you probably would do another request to the server, and it's get back. In Firebase, it's not the issue, because Firebase, when you instantiate a Firebase object and attach particular URL, Firebase listening to this data. If anything changes, Firebase automatically pulls synchronize not only your client and the server. It's automatically from the server. It goes to all the client connected to this website, to this application. So, and integrated authentication, which I highlight a little bit later. So, Firebase Management Console. I will show. I showed you a little bit of it. Let me show you maybe some code examples, so you can kind of see what's going on. So this is my database. It has some nodes attached to it. I'm interested right now in the movies because I'm gonna be operating on this on those particular movies. This is a simple application. I will show you code in a second. So as you can see, the top part is I'm running it locally from my file system. This application, the application below, it's actually I deployed the same application on the Firebase hosting, so it's out there, and this is my Firebase console. So as you can see, if I, for example, creating some kind of movie, let's say, any favorite movies? Anyone? Which one? Deadpool. So you can see that it listens everywhere. Once I attached a listener to a particular database I'm using, it synchronizes everywhere, every client. So this is my local environment, this is server, and this is as you could see, there is some green updates. If I add some movie, one more, other, you could see it just synchronizes immediately, and the data already there. So let's look at some code and how it actually works. So this part, as I showed you from the beginning, this is kind of required from you to kind of configure your Firebase instance, and this is reference. Reference is something which corresponds to unique branch of my Firebase database. Right now? Oh, okay. Yeah. It's better. So this part is just configuration part where I initialize my Firebase object, which I'm gonna be using later. So this is this part where I actually checking get a reference to a particular point where my movies in this example are. So let's see a little bit of code and how it works underneath. I will show you many of this code is just plain manipulation of the DOM, but I will highlight only a couple of things, like for example pushing to Firebase. Refresh UI is just a list of our movies, which I updating every time something happens. Those are two methods just for editing, and deleting my data. So using the same reference to my particular to my movies, I'm just it's a simple CRUD operation: update, write, delete, and read. Any questions so far? Everyone clear how what is this about, and how would you use it? Yeah. All right. And last thing, this is my reference, and this is pretty much most important thing. I attach a listener, so every time the value of my snapshot is the when I have this reference to the movies, snapshot is what I getting back from the server. It's just a data representation of my JSON data. So attaching event listener, if the value changed, I just do some manipulation. In this example, I just pushing to my list array. All right. Code is everyone familiar with the code, and any explanation? Whoa. All right. So I talked about the references. References is just a particular URL where we would like to get some data. We instantiate our Firebase object with the URL of our database. You put your own URL of your database. Then you can have access not only to the root kind of location of your Firebase. You could create lots of references to track any particular child of your data. And one more thing, there is no overhead. There is no there is no performance issue with this to duplicating those refs. It's really cheap operation. So if you have to do this, you definitely would want to do this. So usually when we have a data to go through to particular part of data, it could be a little bit tedious, and just you probably not know what's a child, what is the child. If we have a big tree and the root category root directory is data, it's called data. If you would like to access some data below it, you would probably want to use one of these three methods. It's child, parent, and root. With child and parent, you pretty much can go down the tree and up to the tree, and getting your data, it becomes a little bit easier. If you would try Firebase, you probably one of the first thing you wanna use is those methods. So there are I told before that there is a listeners attached to our data. We have at least, well, we have three methods on our reference. On it's attach listeners value. It's kind of universal listener which tracks everything what's going on, every change with our data. We have also child added, child changed and removed. You would use it in some particular situation. It's up to you. I used an example below just a value, so it's notifying me if there is a event child added, child changed, child removed. It's all of those events are in this particular event value. So if you don't wanna play with other events, you could use just a value. So reference ones. This is a part when if we don't need to synchronize our data with the storage, we probably would like to use reference method once. So as you assume, it just takes once our data, and there is no listeners, and it just takes the data once and stop listening for events. And ref off, you detach listeners from your from refs on. In the first example, so you just detach all the listeners and go along with it. So how do we query Firebase? The queries is pretty powerful. You can combine those queries to kind of do as you do in a relational database. As if you work with SQL, you could select something, you could filter, you could limit, you could do anything you want. Pretty much the same with the Firebase. In this example, I combined few filters to I took last three elements, which is equal to Voldemort, and prioritize them. So this is how you do queries, query Firebase. Okay, and one more thing before this slide shows you the thing about Firebase. It's online. Your database online, and it's available everywhere to everyone. I will show you setup of my Firebase, and I made privileges for all the users. That's, by the way, By the way, yeah. By the way, this is how you restrict access to your users to do something if you would if they not authorized to write, if they are not authorized to read some information. So right now I put some global settings. It means that everyone can read from my database and anyone can write to it. But I want to show you how you would do this. By the way, this is JSON representation. So all you do besides these keys like read, like write, there is not. It's not. It's complicated, but after a couple playing with it, after 5 minutes, it's getting better. So how can you restrict access to your data? You probably would like to your data to read if the user authenticated. If he, for example, let's take a simple authentication. When we authenticate with Firebase, it returns us the user object of object where we can get any kind of information about a user and. So I will show you how in this, for example, particular example, if the user in this example, our data we go back, we go to the parent, and we go to the child tickets. So this means we can read data only if there is a ticket property for this kind of JSON representation of the data. If there is a ticket property and it has children, has child of UID. Of UID is it's a unique identifier for every user. So if of UID equals to particular UID we're trying to get, it's we'll get a read. We'll get pass through this rule. The same, for example, if you would like to write anything, we should be authenticated. So this of object shouldn't be null, and or the child data of our reference has property is public, and is public has to have value. So besides authentication, we could use we can use we can validate data. So as you can see, new data is the new data users pushes to the server. We can check if it contains some kind of string in it. If it's string, if it's we also could use regex expressions. All of different things. It's just a small part. It's just a small part of which you can use to validate the data. All right. So this is pretty much features of Firebase. From this slide, I would want to talk a little bit about synchronization of data. Sometimes. Because of the poor connectivity or some kind of delays, two users can write the same key some particular data, and Firebase handles really smart this kind of situations. It's those keys which Firebase generate for every piece of data, they contains timestamp, and timestamp. This is how if the one request goes and the other one goes first, but because of the delay it arrives later, Firebase synchronize this, and because of those timestamps, so Firebase knows when the request was sent, and actually first after the data receives on a server, it manipulates it and kind of change the order of saving the data. So I'm not gonna spend too much time for registration and login. Firebase just handles lots of it handles, besides the kind of normal email password authentication, you have email verification services and password resets. It's really powerful. This is just a small example how you would authenticate with the Google pop-up provider. Firebase actually has some UI widgets which shows you some already customized pop-ups, and you don't have to write a single line of code. One more thing, Firebase goes with the command line interface. Once you log in, once you open terminal and you log in to your Firebase account, Firebase list, it just opens up, shows you the list of all the databases you have active right now. Firebase init and Firebase deploy, it just starts initialize application and deploy. Actually, I deployed my application with I initialized it today and deployed it, and as you can see, Firebase just automatically kind of created for me a domain where I can access my website. Oh, you didn't see this. Yeah, so this is my auto-generated domain. This is where my this simple example is hosted on the Firebase servers. So I'm a little bit geek about some kind of newer technologies. As you can, I don't know if you were on the last IT talk in DataArt. It was about Angular2, and after playing around with some of the newest technologies, like for example, anybody knows about NativeScript or Ionic? Yeah, so this is just a framework for mobile development. Ionic is a hybrid framework, which means that you're writing your code in HTML, JavaScript, and CSS, and it compiles it in and gives you kind of feel of this native application, but it's not native. It's just a hybrid application, but it works in a web view, but it's really fast. NativeScript it's a different approach, the same as React Native. It compiles all the you're also writing your code with JavaScript, CSS, but instead of HTML you have a kind of XML like syntax. While in NativeScript you have this kind of native app. It's not a hybrid app. It's truly native. It has all the stylings, all the iPhone, Android, and Windows kind of stylization and components. So I would like you to kind of take a look if you're interested in real-time databases, because Firebase it's not particular for all the choices. You wouldn't want it run if you have a massive kind of server logic, or you definitely would want to use Firebase with the mobile app, just for testing your ideas, just for kind of development, because mobile apps they do not have lots of logics. They pretty much just synchronization with the data with the server, just displaying this data. So I would suggest you to take a look at the if you're interested in Firebase, take a look at the NativeScript and Ionic and combination with Angular2. Angular2 is already in release. It was a couple of weeks ago, so it's kind of not really yet stable, but you can play with it. Some of other tools you can use for development, just you can use some emulators like Genymotion. I already played with NativeScript, Genymotion, Firebase, and it's really not a big deal to set up this, but once developing for one platform, you just got for every 3, 4, and data synchronization with database. It's really handy. So about Firebase. Firebase, as I already told you, it was bought by Google some time ago, and it has really good infrastructure around it. So pretty much for every kind of famous framework, you would probably will find a library for it, and it's not really difficult to set up Firebase by its own, but you have those kind of particular to every framework's hooks, how you manipulate data in a little bit better way and more framework-like way. So as I told you, it's mobile, Android, mobile friendly, so you just synchronize your data. You're not using any server and database. You're just using Firebase. Also, recently I discovered there is support for Google Maps, GeoFire. It saves your kind of location, latitudes, longitudes, and it's easier to work with if you work with Google Maps. All right, then, this is it. Any questions?
Is it possible to use one database of Firebase across different platforms?
Can you repeat?
Can you use one database of Firebase across different platforms?
Yeah, sure. This is a point to use kind of only one database across. With the tools like NativeScript, you're just developing once your application. All the logic, for example, JavaScript logic stays the same. You just have to adjust your view representation. Like, for example, in Ionic, you have to use Ionic tags for kind of displaying information. In NativeScript, you just have to use XML syntaxes. They are a little bit different, but logic of your apps stays the same. The connectivity stays with the Firebase. The only thing you have to do is adjust the view representation of your apps.
Okay, you showed us how you can subscribe to particular path to Firebase database, but how does it work under the hood? I mean, does it use WebSockets?
Yeah, it uses WebSockets, yeah.
Okay, cool.
So yeah, once you subscribe to some reference, you just if you're not using I showed you the methods on, off, and once. If you're not using once, if you're using on method on value, you just every time data changes, you just got notified. Every client pretty much got notified, and yeah.
Okay, can I add something regarding functionality? I played a little bit with Firebase, and actually you haven't mentioned a few really nice features. For example, you can get like analytics in Firebase. You can set events that will be logged to Firebase and to see how many times the specific button was clicked and so on. And actually it can also fetch all errors that was in your production application and see which part of the application is broken.
Yeah, it's actually a really kind of big topic because Firebase has integrated analytics from the Google, so it's really powerful. You pretty much can track. You can look at those statistics, and you can find, like, for example, how many people comes to download your app from the Poland locations, and how many times they spent just viewing your app. Did they do purchases? Did they not? It's really a big topic, and kind of behind the Firebase analytics, it's just Google Analytics, and with actually Google Analytics helps you to develop your business. It shows you, it's kind of suggests to clients which would probably probably download your app. It also has some kind of suggesting mechanisms. As I said, it's really a big topic, and this analytics stuff. There is a good talk I actually saw yesterday. If you want to, I can attach link to those slides, and yeah, really powerful things. But I wouldn't go through analytics on those talks on this talk.
Yeah, and one more thing that it actually has one really nice feature, which is called remote config. You can set up like initial values for application and configure it for A and B testing. For example, for let's say half of your users, you'll deliver one config, and for another half of users, another config. And in this config, you can put, I don't know, some values that can run one scenario for particular users and different scenario for different users, and it will be handled automatically, and you can analyze analytics for different remote configs, so you'll be able to run A and B tests really easy. It is really cool.
Yeah, most definitely. I wish you would tell anything about it, but yeah, it's my talk.
Okay. No, thank you. It's a really awesome presentation. Thanks.
So, what drawbacks of Firebase have you identified so far?
Well, there is no drawbacks. I would say it's just you use Firebase when you need it. For mobile apps, it's really good. It's you set up anything. You set up all the configuration just in a few clicks. Actually, I'll. Yeah, this is my Firebase, and I created my this sample database just few clicks, and this is it. For I would say for prototyping, for mobile development, it's a really good thing. If you need some kind of better if you have lots of logic on your server, you probably would want to use your own server. And if you use your own server, you probably use your own database. It's better for some things, but there is no drawbacks. It's really cheap. As I said, there are plenty of apps which has 100,000 users and they run for free. So it's kind of free. So
Is it like totally free without
well,
payment?
behind some point you start paying, but it's you have to have.
Thanks.
Yeah.
Okay, let's say I would like to create a shop. What about security of users' data?
So yeah, as I showed you, when you authenticate with Firebase, it's the authentication mechanism is pretty much the same as using it. You probably have a Gmail. There is a really secure mechanism which comes from Google, and now if you set up, it's a really tricky thing to set up privileges and Firebase first time. But if you set up it correctly, it's totally secure, and there is no way you just your data go to wrong hands, can get to wrong hands, and the rules.
Yeah, but let me ask another way.
Yeah.
Is there any way to store this data in some encrypted way?
No, this is the only way. Yeah.
Thank you.
I also have a question. So I came from C# world, and we actually doesn't like to show to the end user the database structure. But as I understood, you store everything in URLs, so everyone who could press F12 can see the database structure now.
No, because well, although this URL is kind of available, you in those rules you set up.
No, I didn't mean the data itself, but I meant the structure, the schema. You write the new Firebase and URL. Okay, I don't see the URL, but I can see the URL/users. I can see the URL/shops. That something. So I can, with a pencil and a white paper, I can build this exact schema of how you store the data, isn't it?
Yeah, but if you configure your rules correctly, the user couldn't really get to your data structure, right?
Okay.
Thank you for talk, and could you give details about how libraries work? Because as far as I understand, it haven't traditional package manager like Bower.json or something like that. Are you only playing just around that Firebase object with vanilla JS or something like that? And if you have something like gulp to run Microtask over CSS assets and something like that.
I'm pretty sure there is for example, for many frameworks, you just download those libraries via npm. Here, I just copied this library from the. Yeah, I just. Once again. Yeah, you could use it via npm. You don't have to use it like I did in a script tag. You just run the put it in your npm config and just run package JSON and just run install. Yeah. Traditional package what? You talk about maybe just once again full question.
You mentioned only scope of libraries, right? But can you add by packages on as much libraries as you want, or just happy about
Well, yeah, you could add any amount of packages to your package.json. Well, there is a few ways. As I understood correctly, the question: are you asking about particular how Firebase interacts with other libraries? I don't see there is a problem. Yeah, that's you're just using your.
what about tasks if I want to modify my code?
Well, with Firebase, you don't actually need any kind of tasks. Pretty much, you just have a kind of reference to the external database. I don't see how you use gulp with the. What would you use it with Firebase?
Some content task. If I want to use ES6 and
Oh.
transmit
Oh, you mean like when you would like to transpile your JavaScript to work with a Firebase? I didn't check, but I'm pretty sure there is a library. There is a kind of support for Firebase with ES6, maybe TypeScript, and yeah, I don't really know. Yeah. All right, thank you.